Today's lesson is on domain and range of functions. So in Algebra 2, when we were talking about domain and range, we would often use inequality notation. And now we're going to learn interval notation. It's two different notations that are communicating the same concept. So let's say we have a domain that is saying all x values in between a and b, and then this is including a and including b. So interval notation simply means from a to b, and then including means these brackets. So we're including a and b. So all x values that go from a to b. And now we're looking at x values in between a and b, but now not including a and b. So instead of brackets, we're going to have parentheses from a to b. Same concept from a to b, but this time it's including a, but not including b. So we'll have a bracket on a, but parentheses on b. And then to just switch it the other way, this would be including b, but not a. So parentheses a and a bracket on b. So these are called bounded intervals, which means they have endpoints. So now looking at unbounded intervals, so this is where we're going to think about something going to infinity or negative infinity. For example, if we have x is greater than or equal to a, what is that saying? That's all values from a and then bigger than a on forever. So it's including a and then it's going to infinity, all numbers bigger than a. And then you can't actually include infinity because it's not a numerical value. So we have parentheses. So let's think about what x is less than or equal to a means. It is all numbers smaller than a. So that would be from negative infinity up to a and including a. And now that same idea, except now it's just greater than not including. So this will be from a to infinity, and then this one will be negative infinity to a. No brackets, just parentheses. And the last example is the idea of all real numbers. All numbers is going to span from negative infinity to positive infinity. So in interval notation, we would just have our parentheses, negative infinity to positive infinity. So this right here communicates the same thing as all real numbers. So just again, these are communicating the same thing. It's just transferring from one notation that we have used in the past to our new interval notation. So now actually getting a little refresher on domain versus range. Domain is simply the set of x values, where range is the set of y values. So back in probably pre-algebra, when you were first hearing the words domain and range, you maybe had a table where you just had to say, well, the domain is all of the x values, and you just list the x values, negative 13, negative 3.5, 0.7, and 4.2. And then the range is just showing that you can list all the y values. Negative 2.9, I'm doing just them in order, numerical order, so 4.2, 5, and 12.1. So in this example, at no point did they say it was continuous between these points, so I just assumed they were just kind of separate, discrete points. But now in this graph, I have a continuous function. So it's going from this point, and it's going on and on forever this way. So domain is all of the x values. So if we look, the furthest x value is 1, and then it is going to the right forever. So in equality notation, it's x is greater than or equal to 1. And then in interval notation, it would be including 1 to infinity. So then the range, where are these y values? The smallest y value is 2 and also going to infinity. So all y values greater than or equal to 2, or in other words, including 2 up to infinity. And now we're going to look at equations, and we're going to find when are there restrictions on the domain. So values that might cause problems, x values that might cause problems. And then once you find the problems, writing the domain in interval notation. Okay, so here's my first one. I have a square root function. I want you to think about the square root of numbers. So can you take the square root of 0? Sure. We can take the square root of any positive number, but we're not going to take the square root of any negative numbers. So what that means is everything underneath that square root, the 12 minus 3x, has to be greater than or equal to 0. And now the idea is let's solve for x to figure out what are the possible x values that you can have and that you can't have. So if I subtract 12 over, negative 3x is greater than or equal to negative 12. Divide both sides by negative 3, so x is, divide by a negative, you have to flip the sign, and it goes to positive 4. So what this is saying is that you can put any x value you want into this function as long as it is less than 4 or 4. It cannot be greater than 4. So that would be all numbers from negative infinity to 4 and including 4. So we found the restriction, and then here's how you write the domain in interval notation. Okay, here's our second function. So this time there's no square root, but I do have this fraction. So what might a restriction be? Well, I know that denominators cannot be 0. They can be positive, they can be negative, but they cannot be 0. So x squared minus 2x plus 1 cannot equal 0. And now the idea is to find those x values that cause this. So it's like we're solving for x. We have a quadratic, so let's see if we can solve by factoring. This would go down to x minus 1 and x minus 1. So x cannot equal a positive 1. So one way to communicate this would be all real numbers except 1. So how do we write that in interval notation? Well, all real numbers is negative infinity, but we're going to go up to 1 but not include 1. And then this is like a union notation. We're going to have another 1 and then to positive infinity. And here's the last example. I have a square root in the numerator, and then I have a denominator. So I have to consider two things. If I'm looking at, let's see, underneath the square root, x plus 2 has to be greater than or equal to 0. And then my denominator, x minus 5, cannot equal 0. So the idea is, okay, we'll solve them both for x. So x has to be greater than or equal to negative 2. And then x cannot equal 5. So how do we write this in interval notation? Let's think about this one. So greater than negative 2. So I'm going to start with negative 2. This would be like negative 2 to infinity. But what about this? 5 is in that domain, so how do I write it so it's not in the domain? We're going to go from negative 2 to 5, but don't include 5. And then from 5 to infinity. So there's your full video on interval notation, domain and range, and restrictions on the domain. Good luck with your lesson.